And we're going to have an interesting session with amazing entrepreneurs and people that they're going to talk about various things related to innovation. I want to call to the stage the person that's going to moderate this session, Anya Eldan. She's the VP and head of the startup division at the Israel Innovation Authority. Anya, the stage is yours.
Good morning. Ooh, this is scary. Just show me the clicker. Is this it? We'll figure it out. Welcome to the startup session. I'm Vice President of Israel Innovation Authority, which you know already from Aaron's speech, and I will run this session. We have about 2 hours. I will talk very shortly about a cool new AI program that I'm going to be launching very soon. And then we're going to have 3 very interesting AI startups. They're going to come together with their seed investors, and they're going to have a fireside chat. I'm not going to disturb them. They're going to interview each other and talk about why did they invest in the startup, what did the CEO or founder have, why did they choose this particular investor, and I hope it will give us a lot of insight into what the investors are looking for in the AI world. As you know, there are many, many AI companies in Israel already. After those 3 interesting sessions, we're going to have 3 more startups of the 13 exhibiting downstairs, and then I'm going to come and do a short pitch. We selected 3 areas. We're going to talk about technology infrastructure of AI, we're going to talk about healthcare, and we're going to talk about mobility. And right after me, we're going to have a very special keynote speaker. He came from Berlin, and he's going to give us a keynote speech about how to build AI companies and how to succeed with AI companies. So I will start very briefly, immediately after I figure out this clicker. Okay. So you already heard from Aaron, Israel Innovation Authority spends about $500 million US a year in promoting Israeli innovation. Our role is to help the Israeli industry be successful and competitive. So we're not VCs. We don't invest to make money. We invest to make economic benefits. So we invest our money in the most disruptive, in the most risky, in the most novel technologies to help the private sector succeed. And that's why we call ourselves the private-public partnership. We never give money like other governments. We never give 100% of money. Every time we support a company, we expect them to also bring some private money, because eventually we will step back and the private sector will take over. So one of the companies that you're going to see at the end of the session just told me in the back she raised $12 million. We gave them about $1 million, so we gave them the first risky money, helped them get started. We provide support every stages. So we start with applied research. We don't do basic research, but we start with applied research, with tech transfer. And the people here that come from the university and researchers probably know us. We have a lot of programs to help translate basic research, collaboration between academy and industry, then seed, pre-seed startups, large companies, a lot of international collaboration. So probably if you have an innovative idea, we can help you get started and we can give you money. But in addition to money, we want to do 2 other things in the startup division. One of the things is ideation. So there are areas where companies just happen. And you know a lot of the companies, healthcare, technology, a lot of, especially people from the technological side who come in and establish startups when they see an idea. Sometimes clinical people, you will hear the first couple that's going to talk here about MD clone. You will see where they came from. It's very interesting. But our role is to find places where things don't happen easily. And what I really wanted to talk today is about one area where our help is maybe needed a little bit more, and that is where AI meets pharma, and I mean drug discovery. So this is a very big problem. You probably all heard how expensive it is to develop drugs today, how difficult it is, how much failure it's out there. So all the big pharma companies, even though they have huge revenues, but it takes them a lot of money to come up with a working drug. And we think that's going to change, and this is where AI comes in. And it's happening slowly. I don't expect you to read everything. In fact, I can't read even one sentence from here, but I'll tell you what this slide says. The area of AI in pharma, in drug discovery, it's probably one of the biggest disruptions that's going to happen. This is our opinion. And the interesting thing is that people who invest in the area most are the tech giants. So you'll see Google, you'll see Microsoft, you'll see IBM. You will see much less pharma companies already investing in AI or computational biology. In the second column there, you have a list of investors. And it's okay that you don't see, because practically every leading Silicon Valley investor and practically every leading Boston investor and hopefully every Israeli investor are looking in the space, because this is going to be a big disruption. There is a potential to reduce the cost of drug development dramatically. And on the right side is our ecosystem. So maybe you don't know, but Israel is very, very strong in computational biology. 30+ leading, most cited researchers are Israeli. We have very strong science, but we also have a very good healthcare system, or let me qualify that, very electronic and digital healthcare system. So at least on that side, we're pretty good and have been for many years. And some of it is due to the company that you're going to see here today. We have quite a few startup companies. You see about 10 in this area, in this space. So there is a market failure. There is a problem here. We think that there is an issue of how to translate this computational biology research, basic research, into creating the industry. And this is our role. So we are going to launch a new product, new tender, for innovation lab in the area of computational biology, an AI pharma. And hopefully around this tender, like with other innovation labs and incubators that we did in the last few years, we hope to bring in a collaboration between tech giants, pharma companies, lead investors, and the researchers, and create a sector or a cluster in Israel that's going to be exceptional. So this is really, I'm not going to go into financial incentive. We're actually launching this program on November 27 at Mixer in the exhibition ground. So if somebody is interested to come and listen and understand better, write me a note. And on this happy note, I will stop. And I will invite our keynote speaker. So Clemens comes to us from Berlin. You come on. And he's gonna talk about two things. He's gonna talk about the new and exciting company that he's running, but also about the venture called Merantix.
Automotive.
No, but I want to
Merantix.
talk about the group.
Merantix.
So Merantix group actually creates, they call themselves the AI Venture Studio. They create AI companies in various fields. So we'd like to hear about that and also about your company. Thank you for coming.
Thanks. Where's the clicker? The clicker? Is there one for the?
You have your clicker.
Mm.
You press this, it works.
Okay. Cool. So hi, I'm Clemens, and as Anya just announced, thank you for that. I want to talk to you a bit about turning AI research into AI companies, what we do at Merantix. So, I mean, this is obviously preaching to the choir, but as we are moving from, so I just wanted to start a bit off like why we created Merantix. We started off with the internet in the 90s and 2000s, the main theme being the removal of the intermediary. And we're moving to a new age of AI or machine learning, deep learning, that is all about automation. And the projected impact of that, just according to one study here, is going to hopefully far outpace even of what internet technologies have brought to us. So it's an exciting time, but the question is like, how are we going to build all these companies? I mean, there's great startups here, but like, it turns out that building AI companies is pretty difficult. So when we started Merantix in 2016, it was about, we saw like a lot of great research going on in AI, many papers, more and more breakthroughs, but still what is in application is relatively a little, and what is actually like working in industry is relatively little. So Merantix tried to address this issue by building what we call a venture studio, and I'm going to talk a bit about more what we do there in a second, which is essentially a bit of an incubator that's trying to make AI ventures successful in building like real-world applications for AI. So we really see ourselves as building a bridge between research and industry. So what does it mean for Merantix? We're not just someone that gives a bit of money to companies for equity, but we really see Merantix as a platform for founders that want to build disruptive technology ventures in AI. And what that means is we really have a full funnel of, say, we build our own ideas in-house in like many industries, have an ideation phase. Then it goes to the next stage of, if we say like, okay, this idea fulfills certain criteria that we deem is like relevant enough, we see a good product market fit, and we really want to pursue this. Then we start off like incubating this within Merantix, growing an initial team, and then the next piece is we spin out the company and eventually start to scale it, the company is taking in external funding. Spin-off means really the company becomes fully independent, its own entity, and operates outside of Merantix. What Merantix brings to the table, apart from providing initial funding, is really helping out with all of the things that are particularly difficult in the space of machine learning. So one, helping out with attracting the critical technical talent that is required to build these types of companies. We have a baseline infrastructure in terms of to train and to test models, and just to get started early in terms of building fast prototypes. And we also help a lot with industry contracts and strategic support in terms of like what makes a good venture in the space of machine learning. So this is what we kind of call the Merantix platform. So in the past 3 years, we have spun out, so in terms of like a scaling phase, 2 companies. So the one that I co-founded and that I'm going to talk a bit more in this talk about is the Merantix Automotive, where we deal with the data overload problem and the infrastructure challenge in autonomous driving and ADAS. One example, we have built a company in healthcare that's actually the first and largest venture that we've built. Already it's in the space of automated diagnostics. And we also have one venture we call Merantix Labs, where we build custom-made industry solutions for customers. And this is more like a solutions practice. We use this one to leverage the learnings from the ventures that we're building, but also to get new ideas of things we want to build. Beyond these things that are like the most mature, we have half a dozen more ventures in the pipeline that are in the incubation phase right now. And so there's a lot more to come. So over the past years, when I said earlier, it's actually pretty difficult to turn AI research into applications. We also wondered, like, how is it that it's like so difficult to really transfer all of this great performance that we see in the research applications to actual real-world applications? I want to talk to you a bit about that particular piece today. There's commercial challenges as well, like how do you find a good business model? How do you get access to the right training data? How do you deal with law and regulation? And all of these topics. But today I really want to focus on what makes the difference between great performance in academia and in industry. So when you think about how machine learning or AI works in the academic setting, you typically start out with a fixed data set. So that can be MNIST or ImageNet and computer vision, or sometimes you just deal with some data set that you just encountered or you found or you have access to. Then you start putting on a model on top of that and try to squeeze out these extra percentage points to really like improve upon the state of the art. The researcher has then reached a higher performance than all of his peers. He can publish a paper, and our co-founder Rasmus, he used to joke, like, in computer vision these days, like, you do this 3 times, you get a PhD. So this is kind of like the workflow, about who am I to talk? I don't have a PhD. So this is kind of like the model, how it works in academia. When we look at the industry, the workflow is actually the other way around. It's like completely upside down. You typically start with a fixed performance target. So say you want to at least detect 95 cancers or only have that many incidents on autonomous driving over X million or billion miles. So this is where you start. This is the requirement that you need to fulfill in order to commercialize something. Only then you start to even think about, like, what type of models do we need in order to fulfill that? And then if we know, like, what kind of models we need to fulfill that, what type of training data is available to reach that, or what type of training data do we need to get to achieve that? And there's actually quite some variability and flexibility with regards to these latter 2 points. And I'm now gonna talk a bit, like, give you a few examples for each of these steps. So yeah, it's because it's like really, there's like a lot of implications in terms of when you build commercial applications for that. Starting with performance. So autonomous driving is a great example for the first point of performance. There's typically like a relatively binary success criteria for the success of a specific AI application. So it won't be good enough if you build a self-driving technology that like drives safe most of the time, or if you basically detect cancers most of the time. You actually have a very fixed kind of like way. There's a hard threshold of what you need to achieve. And here you see, like, this is the theory, and then this is the reality. Like a single accident, like the Uber accident in 2018, caused like a lot of public outcry in terms of the safety. Sometimes even creates a bit of a biased view in terms of like what do the algorithms need to achieve versus what do humans need to achieve. But it's definitely like the perception and the requirement in the public mind is there is a hard threshold in terms of like what do you need to achieve in order to be commercially viable in the first place. So typically, it becomes a solution becomes commercially viable if you somehow reach the threshold of like, oh, we're performing at least better than humans on a specific task. That could be like in radiology as we work here, or like in the specific driving task. So in order to actually achieve that threshold sooner, there's like kind of like 2 key things that you can do to get there sooner. So one is you can focus on support systems. So you basically don't let the algorithm take over the whole task, but support. Example would be in cancer screening again, in radiology, you would exactly like build a system that assists the doctor in finding cancers, but does not like fully take them out of the loop yet. The other way to quote autonomous driving here, like, and this is what a lot of companies are doing, is you actually constrain the environment by a long margin. So you say, we only deploy cars in retirement homes, or we do delivery first, or trucking. So you basically really constrain the scope of like where you're operating in order to achieve the required performance to have a commercially successful business in this space sooner or quicker. The next point is about the way that performance is even like perceived can be very, very different. So this is some pictures here from the MIT model machine. You can play around with it as well a bit if you're interested. It's basically like tells you what an algorithm is outputting, and the way this is perceived in terms of like good or bad can be very, very different. In terms of here, you have some examples from autonomous driving again. And what is interesting about the MIT model machine, you can fill out the survey and you can see a couple of results, even like between countries and between age groups, etc. There's lots of difference in terms of how these decisions would be made. So when you actually build a solution that you want to deploy somewhere, like the way that companies perceive, the customers would perceive how your system is performing might actually vary widely, quite a bit on who's the respective audience or user. The next thing is, in order to successfully deploy machine learning, one has to really work with training and test sets, and you need to make sure that your training set is as close to the real world as possible. And in order to achieve that, to make your system, your training data be as close to the real world as possible, really need to know your target and your deployment environment. And what that means is, here to say again on the autonomous driving example, you need to know your relevant context. Where are you going to deploy it? What city? What is the typical weather? What are like the typical driving customs in terms of how our drivers typically interacting with each other? So that's like the relevant context. Then you need to take into account that the environment is changing as well. So you might, for example, have new vehicles coming in, scooters coming in, or for autonomous cars, you need to make sure like that you can deal both with the increasing number of self-driving cars that are also on the road. So the environment is like constantly changing, and so needs to be the data that you're working with. And lastly, even more, to make it even more complex, the technology that you're going to deploy is also going to change the behavior of the people that engage with it. So your own technology has an impact. So for cars, that would be self-driving cars will be perceived differently by pedestrians than manually driven cars, or in healthcare, like if you have as a radiologist a system that you can rely on partially, it will change also the way you engage with making diagnosis in the first place. The next thing, and this is like really crucial also to what we do in Amex Automotive, so it's the problem of overfitting. So here a great example, research by Recht shows that they did a bit of a test that they're taking a few state-of-the-art image classification models, and they were typically tested only on a very specific and always similar staying test set from Cypher 10. And it's interesting because they did this always testing on the same kind of set in order to have comparability, but then this research showed you just take a few different images as a test set and the performance really like drops very markedly, very quickly, even though the distribution of this set was like relatively similar. And that is super relevant because it essentially tells you that in order to really maintain a certain performance and avoid overfitting, you do need to constantly update your training and specifically also your test set. And this is like what we deal with in Merantix Automotive. Great example of overfitting that from our own practical experience is also in autonomous driving. Say you drive along a certain route a lot of the time, so every single day you drive the same route, and you see the environment as it is, and you need to do that because you need to make sure that this route, maybe you want to deploy your car there, works very well. So then there's a car parked on the right on this garage like every single day, and then you will typically find that a very, very vast majority of perception algorithms, they will actually tell that there's a car on that specific space even if the car is not parked there anymore, because it just like overfits to the type of environment it like perceives usually. So to sum it up on the performance side, so one, there's very binary success criteria for AI typically. Then in order to deal with this, one good strategy is define and limit the product scope on where you're going to deploy it. And that is very well connected to, you really need to understand your target environment, so it was 4. And then there's also a difference in terms of the how performance is even perceived by the public. And lastly, you have the very difficult problem of overfitting. Moving on to the model space. So for the model itself, there's the first typical challenge is like, what are you actually optimizing for? So we have two examples here again. So say you want to build an AI to make money in the financial markets. Like one objective could be to be like very accurate at predicting the market, so you could optimize for that loss, but it would probably be more beneficial to actually directly optimize for the P&L loss that your model is performing if it executes the trades. So kind of like taking out this intermediate step, similar for cancer detection, you could just be very accurate at detecting a cancer, or you could be very accurate at detecting no cancers, which is typically probably more beneficial if you can then be a lot more efficient in like sorting out like unsuspicious studies. Another problem with the model side is that the loss or like the loss is like non-equal in terms of commercial applications. When you think about that from a diagnostics perspective, when you diagnose a healthy patient, then this is when you have actually like diagnosed someone that is actually healthy, there's not a big problem. On the other hand, when you actually fail to diagnose a sick patient, then that's like has huge implications, not just from a commercial perspective, but even for the life of the patient. So there's a very, there's a strong emphasis and a strong need to be really, really diligent of avoiding these kind of like losses in the model. Next thing is industry doesn't like black boxes. So in academia, it's like typically fine to say like, oh, we have this like new state-of-the-art model here, and like just outputs great performance. In industry, however, typically people want to really understand like what is going in, what is coming out, and how are decisions being made. And the reason behind that is typically how if we actually put something into application in many countries, there's a strong understanding of like there's a requirement for who takes over liability if something goes wrong. This is why in real-world applications people really have a problem with like having a total black box of we don't know what this model is doing, but it's just output something great. It's something that's very hard to explain in a lot of spaces, particularly in heavily regulated environments like in automotive or in healthcare where we're active. And there's always a big trade-off here because on the one hand, deep neural networks address problems in a new way compared to like rules-based systems. So we actually use these systems because we say, oh, the model, the real world is too complex to just put it into rules. So we have these neural networks that actually like deal with it in a more intelligent way, more similar to what we're doing, even though we're not understanding all of it. And the more complex the model that we're applying to it, the less explainable typically it is how this model actually engages. There's a lot of research going into explainability of models. Interesting about that research, though, is oftentimes it changes pretty quickly. It's a bit like nutrition research, where like there's like new things being discovered like every year, and they're quite opposite directions typically in terms of like what does a model actually see or how does it decide. There's a lot of ambiguity in that field. Next thing is on the model, and the last thing I think here on the model is that size of the model and the application actually matters a lot. So typically in the real world you have very, very strong constraints on like what you can actually implement. So when in research it might be fine to say, oh, we just like take the most complex model, we don't really care how long it executes, we don't really care how much compute it takes. If you're actually in an environment like in a self-driving car, you have like limited memory, limited bandwidth, limited execution time, you need to recognize pedestrians as fast as possible and as accurately as possible. And this becomes particularly difficult if the hardware that you're executing this on is also very constrained in terms of like maybe there's even a cost factor in like what can be be available in terms of compute at any given time. And yeah, the last point, which is also typically a very bad misconception in AI, is like many people think if they just take the latest of the latest and implement it, and then it's going to be like the world-leading commercial application. That is typically not the case. And actually in many, if you look at anything that's really like running today in like applications that are commercially used, state-of-the-art models are typically not even required. So it's typically like a few years old models that are already established that are like enough or like actually more robust to achieve the relevant performance in a given industry application. On the other hand, it's and this is what we also encounter in a lot of spaces. Sometimes you read like a nice paper and it says, oh, this looks very good, and this is a very great thing that we can maybe achieve here and like really improve this performance, or let's just try to implement this. So you try to implement a paper, and the paper was like done on MNIST or like a very small data set, and then you actually see, okay, so it doesn't really work with that with a real world data set. So yeah, so for good example is always you get these great performances of detection of cancers in research papers, like when you actually deal with real world data, the performance looks like very, very different. So to wrap this up, one is like know what you're optimizing for. Two, you of course need to take into account the unequal cost of making a mistake. The third piece is you need to make sure that you can actually explain at least partially what your AI is doing. Then the constraints in terms of memory and compute. And lastly, also oftentimes is actually not required to implement state-of-the-art or might even be counterproductive. Lastly, I want to speak about the training data in itself. So there's typically three types of data. So one is the data that you already have and that you have labeled. And then there's like two other types of data. One is the data that you have but it's not labeled. And then there's the data that you don't have. And the latter two parts, they really are connected with cost in terms of like one, acquiring the data, and two, labeling the data. So one of the biggest questions today in many real-world applications is how do you minimize this cost, but how do you maximize the performance? And this is a tricky question, because if you deal with smaller data sets, it's not that big a problem, but as soon as you deal with really large data sets, such as in autonomous driving, then this becomes one of the most costly questions that you actually deal with. The other part on the data is typically that the academic data sets, like here Amnes or ImageNet, are well balanced, very standardized, very clear data sets. And so you can train a model very fine on it. In the real world, say you want to detect cancers, you have a very unbalanced data set. Of course, only very few percentage points of say, women in mammography develop breast cancer, so the data sets that you're dealing with necessarily are heavily skewed. And then even worse, the cancers that are the biggest and the largest, they're even more rare, and this causes a big problem. So we encountered a problem, for example, that the model was relatively bad at detecting very, very large cancers, and and this was because these occurrences were actually very, very rare. So another point is about the quality of labeling. So we see that low quality labels can actually impair performance very heavily. So we really need to make sure that you have a very, very strong quality process for labeling your data in place. To sum this up, you need to consider a cost and benefit trade-off between acquisition and labeling. I'm going to talk about this in Amex Automotive for a few minutes. And the second point is focus on rare samples. And third, really make sure that you get highest quality annotations. So as I said, we're building a couple of companies in Merantix based on all of these learnings. We've also failed in the past. So we tried to build something in high frequency trading with crypto. That caused a problem in terms of getting the execution right. We tried something on online ads efficacy. That was not super successful. We also did some parts in a simulation that we were not super convinced of. But we also done a bunch of things that work pretty well. So the first, as I said, in healthcare, to just give you a very brief overview, it's a big problem. Mammography is a big field that is in AI. So we have one of the largest data sets, over 2 million studies, a CE-certified tool, working with many hospitals in Europe, and working on a full rollout there. And the model here is to really use smart elimination. So we eliminate healthy studies and hence really accelerate radiologists in their day-to-day work instead of focusing on them being very accurate with cancer prediction itself. So it's called VARA. If you're interested, look it up. Next point is on Amex Automotive. So what we work on Amex Automotive, in autonomous driving, and I need to hurry up a bit, I was told. In autonomous driving, one of the biggest challenges is, as I just outlined before, is actually that you collect a real lot of real-world driving data to train your models in perception and planning and for testing. But this data stacks up extremely quickly. So you constantly need to update your training data test set, but your data is large. At least 1 terabyte per hour per vehicle goes very quickly into petabytes of data. And how do you actually maintain control of this? The problem, if you actually want to engage with this data, you rely on manual labor. So today, companies spend a lot of manual labor in terms of sifting through real-world driving data and just looking at it with actual engineering hours that are super expensive. And the result of that is that the utilization of all of the data they collect is extremely low, less than 5% in typical cases, and this causes crazy inefficiencies. So you spend a lot of money to have the cars and a lot of money to record the data, and then you use very little of it. So we built a system that we call Redfish at Amex Automotive that essentially is a search engine on, this is a bit bad formatting. There's essentially a search engine on autonomous driving data. So it's cloud-based application that ingests all of the raw data and automatically indexes it like a search engine. So it's basically creating a full meta index of the data that you've collected fully automatically with tags, and then enables the user to just search through it and take decisions on what data you want to archive, or what data you maybe want to record in the near future. So it has a few basic elements, one is extracting it, the real intelligence part. This is the only machine learning part, and then a lot of data engineering in terms of making sure we can process petabytes of data in parallel, billions of rows of metadata in a relational database setting and making sure that the user can engage with it in a UI and API. So yeah, we've built like a nice front-end API to really like engage with this tool, and really the value proposition is mostly about, one, automating a lot of the work. So a lot of AV engineers today spend more than 30% of their time just looking through data manually, and we're really looking towards automating this part of the game. And the second part is optimizing storage. So as I said, like storing a petabyte costs you $500 million per year. So we really look into like identifying where are the empty highways that no one is interested in, or what data is implicated, and just archive and delete that data away. So we really try to optimize infrastructure cost. And lastly, we also aim on like enabling users to just find answers to like fully new questions, such as, oh, what should I like record to really improve my performance? Or I have an interesting failure case, maybe I can find similar sequences in my raw driving data. So we like, we've been around for a year. We have like a bunch of pilots going on, work closely with cloud providers, and have some interesting research projects going on. This is me and my co-founder, Mark, that run this. So what else are we looking into at Merantix? Just to name a few fields, as I said, there's a few ventures in incubation, insurance, cybersecurity. We have like some interesting applications in legal tech and RPA, and manufacturing as well. So there's lots of things going on. Make sure to visit our website and have a look, or if you're interested, reach out to me. The Merantix companies today, we're all based in Berlin, employ more than, or close to 60 people today. We're a very international team. If you're interested, don't hesitate to shoot me an email at clemens@merantix.com. And yeah, thanks for your attention, and hope that was at least partially interesting. Yes.
Thank you, Clemens. What am I doing wrong? Yeah, I got it. So thank you for coming from Berlin. And usually we have a lot of people coming here looking at our startups, looking at our models, and it's great to learn from other people's models, I think. We're now trying a new format, so bear with us. Instead of having a panel and me asking questions, we're going to have 3 couples asking each other questions. So I think it will be great, and I will be able to listen, which is always great. So the first company is MD Clone, and I'm so excited to have you, Anat. Anat Nashitz, managing partner of Orbimed. She's the, I don't know, is it right to say investor or one of the founders or finders? Anat creates companies from nothing. She has ideas. She's looking for smart people. If you're smart people with great healthcare ideas, I can't recommend Anat better. And Chovav, Chief Scientific Officer of MD Clone. And let's see what they have to say. Go ahead. Yeah, I think you have mics.
So after this introduction, I can only ruin it. So thank you, Anya. I think we have about 15 minutes. The focus is the company, and I love this company, so I'm hoping to get Chovav to tell us as much as he can about it. Just 2 words about us. So Orbimed is a large global healthcare investment firm. We manage about $15 billion. We're integrated throughout various geographies, US, Asia, Israel. We invest in biotech quite a lot, and digital health as well, and devices. So we're quite broad. We can do anything in terms of stage, from start to maturity. And MD Clone is a company we love, invested in when it started, more or less. So, and Chovav, you want to say a word?
Hi, Chovav Dror. I'm the Chief Science Officer, and most of MD Clone, I hope, will come from the questions. I had my PhD in statistics here in Tel Aviv, and before that, I was in the military.
And he's one of the smartest people I know, just, to be clear. So, tell us about AI and MD Clone. What's AI about MD Clone, and what does MD Clone do that incorporates AI, and what are the other elements that make it a solution?
Viernickel has AI in two different ways. One way is how do we make our own models? How do we make privacy solution, which is synthetic data? How do we do other things which rely on having models under the hood? But I think the more interesting one is having an eye for our customers, because Viernickel enables people to use data, which otherwise they cannot or they can in a very long process. And more than anything else, the ability to get to the data is much more important than the models themselves. And everybody are like to joke about data scientists, and I'm from the family, spending 85% of the time preparing the data and 15% of the time complaining that all they do is preparing the data. We'd like to change that. And once you can have easy access to data and quality data, it's all different.
So I'll make it difficult. A lot of people say they can make data accessible. Why are you able to do things they can't?
It's a great question, because we looked at the same things and we thought, why don't people have access to data? And in a way, we evolved over time. We began with a privacy solution. And privacy is quite understandable. We have a lot of regulation. We're dealing with healthcare, and healthcare should keep our data for good reasons. But the result is that almost any startup and any company, and even every hospital, trying to use medical data is actually blocked. And there's so much regulation in order for you to touch what you really need that it takes ages. It just doesn't work. And we realized that this needs to be changed. In the beginning, we actually just wanted to get data to do things ourselves, and we understood that's not going to happen. So it began with that. And then we thought, well, that should be enough. But it is not. We thought that once you have privacy solved, then you can easily access and query the data that you actually need. But when someone wants to get the specific herd of people and the specific details about them, it's usually a really long process that involves so many people that most people don't even go to ask a question, even if they have an RB, a Helsinki approval to get the data. Furthermore, let's say you have that and you have the other thing as well. The data is usually a mess. The data is something that most people cannot use. And once again, they rely on so many mediators that it's becoming impractical to use the data. And once again, you're blocked and people do not use the data. And finally, it's a skill set. If you're a physician, you want to do what a physician does, and you want to query your data, you want to do models on top of the data, but you're not a data scientist. If you're a data scientist, you're not a physician, but you still want to get the right things. And if anything that you do needs to have a group inside, and everything needs to have committees, and everything needs to have another approval committee, then people do not do anything with the data. It's actually stayed in its silos, unused.
Why is synthetic data irreversible, and why does it represent reality, and why is that better than anonymized data that people use now?
That's a complicated question for a short period, because people do not even know what synthetic data is. Well, when we're talking about data privacy, the most common term is data identifications. Some of you may think that just removing the names or the IDs will be enough, but most of you probably know that this doesn't guarantee any privacy at all, and that's usually easy to crack, and most commonly getting data from another source and crossing it, and then understanding who do you have inside. There's also methods that adds noise to the systems. Even things like differential privacy, basically what they do is trying to sophisticatedly add noise to the original data. That doesn't work. There are so many ways to get over that, and when it's not, you get no utility of the data. So the idea here was, can we, instead of destroying the overall pictures and still have security risks, can we keep the overall pictures and have no privacy issue. Now, I know this is not intuitive to most of us. We tend to think today that nothing can be hermetically sealed, and privacy definitely is something that does not exist, but this is not true. And I can give actually a simple example to make it really simple that privacy can exist. The question is, can it exist and at the same time keeping the utility? And surprisingly, the answer is yes. When we began, I thought the idea is crazy. Let's just see how far can we go. But when we worked on that, we realized that this is actually achievable. And synthetic data, what it does, and there's many people using the term synthetic data today in various fields, so not all synthetic data are the same. But when we're talking about synthetic data, we're talking about something that does not create patients from real patients. So we don't have a one-to-one ratio, ever. We also take a group of patients, understand what's the right group to make, create models from that, and then create new sets of patients. They're fictitious patients. We can create as many patients as we want. Now, there are many other security measures in what we do, but in a nutshell, that was created impossible to go back and find a specific person, because we never created any one of the synthetic patients based on any single real patient.
Give me an example and give everybody here an example, or maybe a few, of real live cases that hospitals have been able to gain insights or create productivity or create better clinical guidelines, or things that are real live evidence that this is better and that your customers like it and use it.
So that's an easy one, and there is so much in any level of complexity that you want. I think one of the first examples here in Israel, where we began, was a physician coming and saying, there is a myth in my hospital. People are using the wrong drug for a specific kind of patients. And she wanted to check and actually prove that it's a myth and they should use another drug. Eventually, she found out that she was wrong and the myth was right. But it was really easy to draw out the patients from both the test and the control group, see what who are the patients that should be in the cohorts in each one of them, and compare the two synthetically and see which drug is more effective for these patients. And that was published. So that's both came into practice in the hospital and in the Best Diabetes magazine. Today, people are using it in many other, some still simple but very different, some very complex ways. For example, there are many people crashing into the hospital with severe conditions, which we could have predicted a few years before. And sometimes it's as easy as getting to the people 3 years before and say, you're in a risk group, please go and have a lab test. Because we just see that the person is not testing himself while he's in a risk group. Or we see people, we had a prediction model done in one of our US customers, and we try to see who are going to be those really expensive people that are going to crash in the hospital one day saying, okay, we have nothing to do right now but dialysis, and you're stuck to the machines 3 times a week now for your life. And we saw, for example, a very simple thing. Those patients that were already in an identified risk group that did not meet a PCP, their regular family physician, at least once or twice a year in the years before, were the people that are going to crash inside. It's simple as that. And all they need to do, get a program with care coordinator, calling those people, and they're creating lists every 2 weeks to just look who are the new people meeting the criteria, and making a phone call, and all they do is say, please go see a physician. Now, the prediction model is more complicated. It's decide who are the people we should really make the call, because we don't want to call thousands of people. We want to call the right people. So to understand the complexity, it's all inside. But the action itself can often be very simple.
So don't say who it is, but how many patients have they already called in?
Currently, over 2,000.
And that's been just a few weeks, right?
That's in about 6 weeks. Yeah.
Cool. I think we're running out of time. So do you have one more thing to say that's important about MD Cologne, or do you have a question for me?
So let me ask you. First, let me thank you to be the first one who believed in us when everybody thought that we were nuts and we should get some medical advice.
Thank you for being worth it.
And, you know, there's a big hype about AI and the industry in general. How do you recognize a good idea from another one which is more of the same?
Well, first of all, I never proclaim to know what good it is until after it becomes, so it takes some time sometimes. So I don't. I have some hunches right now. Obviously, people know those things are really true. It sounds banal, but it is what it's all about. I think if there are 50,000 people trying to do the same thing, maybe I shouldn't. So those are the things I try to avoid. And I think in the end, for me, it is about making a real difference to clinical practice and to patients, which is why I try to connect the dots towards less efficiency, productivity, cost savings. Those are important, but they don't matter in the end to the ultimate patient. It is things that are around care, and I would love to drive as much as I can innovation in that direction. And I think in addition to what you guys are doing, if I think about two sort of themes, it's that, and it's connecting biology to AI, which I think is something that Anya is working on, and I think is going to result in wonderful things, because that's where it's going. It's using that to develop better drugs to enable more patients to live longer and healthier and, you know, be happy. So that's my personal bias.
When we began, we were a privacy company. And soon enough, we began using population health management. Now, both use AI, and both has a lot of things in common, in liberating the data and transforming care, but that was a very big change. How much change do you expect a young startup company to have in the first years?
I think companies that don't change in the first years aren't thinking. And a lot of the changes that we went through at MD Clone were the result of interaction with customers, right? It wasn't just us sitting in a room in Beersheba and looking at the beautiful blue sky and saying, wow, let's do something different. We went out there, you guys went out there, I was just sitting on the sidelines, but went out there, talked to customers, installed the system, got input about what works and what they need. And, you know, I'll never forget the first installation at Rambam where there were, I don't know how many hundreds of people in that auditorium, and people literally just pouring in and saying, this is what we need, can you make it for us? And you did. So I think that's what it's all about. And if you're staying where you are, you're not going to be successful in this area for sure. I think Anya is going to get rid of us now. Good. Thank you.
Okay, thanks.
Thank you, Chovav.
So while they go down and the next couple comes up, please come up. About 5 months ago, Kobe and I were on a panel on this stage during the TMTI conference, and I said, Kobe, I'm doing an AI panel, do you want to come? And he said, it's so boring. So he came up with this idea of the fireside chat. I hope it works for you guys. We'll do 3 of them, and in the end, we'll take a vote if it's better than a regular panel or not. Kobe Samdursky, co-founder of Glilot Capital. Jonathan Appel, CTO and co-founder of Upstream Security. The stage is yours.
Thanks, hi everyone. So now I'm to blame if this setting does not work. First, I want to thank Anya for setting this up and inviting all of us, and also Gili and Professor Ben Israel for organizing all this. I happened to be in the first Cyber Week here on stage. I think it was 8 or 9 years ago. Sorry? 10 years ago? Wow, time flies. And it became such a huge thing, and I'm sure that AI Week will become the same, probably faster. So with that, maybe a few words about Glilot, and then, of course, Jonathan will take most of the heavy lifting here. So we are an early stage fund, started around 9 years ago, doing mostly cyber work, cyber and AI. Starting very, very early to invest, and I think our major thing is putting a lot of effort behind young companies to really try to help them go to the market very, very quickly. This strategy worked very well for us. Already enjoyed 7 very good exits. Actually, the first 4 companies, and then 6 out of the first 8 companies. So things are going very well. And actually, Upstream is one of the good companies. Just completed a very big round, $30 million round, and a young company still. So, Jonathan, maybe say a few words about Upstream. Why is it so great?
Hi, everyone. Thanks, Kobe. So pleasure to be here. First, I'm going to say a few words about what we do. So Upstream secures connected vehicles. Now in 2020, hundreds of millions of vehicles are getting connected to the internet, and we provide a solution for connecting them. Our solution is purely cloud-based, data-driven, AI-based, and the other thing is that we secure not only the vehicles, but also the mobility services that are actually used over the connected vehicles, and these are like remote car applications like GM OnStar, Hyundai Connect, Toyota Connect, etc., car sharing applications, over-the-air updates, all of these services that actually make up the new connected cars. So this is what we do, and with that, maybe Kobe, I'll ask you, as our seed investor, why did you choose to invest in us?
That's a good question. So I have an answer that has nothing to do with AI, and an answer that has something to do with AI. So I'll start with the first one. You know, we like cyber a lot, and looked into cyber for automotive for quite a long time before we met you guys, and ended up not investing in anyone else. I think the combination of course, a great team, but also a product that you can push to the market very quickly, even in a market that does not move quickly, and also covers a very, very wide range of use cases. That was the main thing. The answer that is more AI-oriented is, of course, we love AI, and we see lots of companies that come with an AI story. But honestly, in many cases, this is just like a cover-up, or maybe like overusing the term AI, right? In this case, I think it's quite a unique case where the amount of data is so big, and the use cases are so different and variable that that AI is almost a must. And AI and deep software, you know, whatever you want to call it. So for us, this was a great combination of a great market looking for a solution that hopefully you can push to the market quickly, but also really use of AI that can really create a leverage over other players the long run in the market. So that was the thing for us. Right. So one of the things that we're seeing with many companies is that are doing AI is collection of data becomes a big thing, specifically if you are a young company and you want to create impact very quickly, and sometimes just collecting enough data to be able to start really building your models and improving them is a big thing. And specifically in the space that you guys are in, automotive, you know, not a fast-moving space, as I said before, and collecting the data is not easy. So maybe you can talk a little bit about the process of getting data from big OEMs. How difficult is it, or was it, and how successful you have been in the last couple of years?
Sure. So you know, first of all, I have to share that the automotive market is notorious of being like a slow market and a difficult market. But when we came to the market, we actually discovered that it's like any other market. So the players, the automotive players, and especially the big ones, are conservative, and they see their data as their prize asset. So of course they won't share it easily. They will only share it for a good reason. So, but the thing is that cybersecurity is a good reason. So automotive companies are well aware of the risk of connecting cars, and you know, I'll give you just one example. A recent study from this year from Georgia Tech, they actually investigated what would it mean to attack remotely a single car brand of a single automaker. And they did some calculations about it, and they said that if I attack remotely a single car one single car type and make those cars, for example, stop, that can actually shut down an entire grid of a city. So the risks with connecting cars are significant, and the customers are aware of that. And this is why they're willing to invest and trust anyone who they believe they will solve the data. So that's the first part. And the second part is, and that's, I think, common to any company. So in order for someone to give you their data, you need to be trustworthy. And trustworthy means that you'll guard the data and you'll keep privacy. So privacy is paramount in the automotive industry and actually in any industry today. So the second part is that you need to be really a trustworthy partner. And I think that as a company, if you offer a solution that solves a real problem that is of value to the customer and prove that you're trustworthy, then you can get your data. And to that end, the automotive industry is like any other industry.
Can you give us maybe some examples of the amount of data that you collect, how much data is created by any car, just to give the audience here some idea of what you guys are handling with?
Sure. So cars, they're machines, and they're very complex machines, but they're also predictable machines. And I would say that there are two essentially types of data that we collect. One is the vehicle telemetry, which can be quite complex because, as I said, the car is a complex machine. And the second part is the mobility services stuff, which essentially is the way the services and the application actually communicate with the cars. And what we do is that we collect data from millions of cars. And this gives us, and by the way, not only millions of cars, but millions of cars from multiple types and multiple makes. And this kind of gives us very good visibility of the market and base to build strong models, which is very interesting task, but also very challenging task. This is why we also need like great researchers, and we're happy to, whenever we have an opportunity, we're always happy to recruit great AI researchers. So let me ask you maybe.
Sure.
So
give me the tough ones.
So as an investor, and especially as a seed investor, when you see like entrepreneurs, so obviously you look at the business models, etc., but is like proven skill set or experience in AI like a real advantage from your perspective?
Yes, definitely. Again, AI is becoming super important, I think, not just for us, for other investors as well. And as said before, lots of people talk about AI, but don't really understand it and don't really implement it. So getting people that really understand is super important. But I do have to say that, again, AI, or I would even say technology, is just one component, right? So first, of course, we look at the team, we look at the business, we look at the use cases, and technology or creating this barrier on the long run is super important, and AI is part of it. Another way to look at it is the way we see most of our companies now, and maybe that's a simplification, but that's the way a big part of our portfolio looks right now, is you can look at 3 layers in terms of architecture. Like the first layer is data collection. The second layer, data collection includes also cleaning, normalization, all this stuff that is, maybe a bit boring, but super, super important. And you are smiling because with you guys, it's also a big part of the work. And then the second layer is more like the technology or the deep technology layer. That includes all the AI and other things. And then you have the application layer or the visibility layer. So how you present this insight to customers, right? And all those layers are super important. AI comes in the middle layer, and to me, this is really the basis for creating a company that will have an advantage on the long run. So initially, you have to create all those 3 layers to be able to get to the market very quickly, and maybe not putting too much emphasis on AI just because you don't have time and you need to run quickly, you don't have data, and so forth and so forth. But you really need to create the basis, and you need good teams that will be able to create the infrastructure for it so that in 2 years, 3 years, 5 years, you'll have a real advantage over newcomers in the market, and that's super important.
Great.
Okay. So give us the secret, secrets. As VCs, if you were, sitting in my seats, what are things that investors don't really understand in AI that as a founder, entrepreneur, and CTO, you think we should look more into?
Great question. I think what I would say is that developing true productized, ready-to-use, generalized AI technology takes time. So, I might come as a young entrepreneur to a seed investor and say, I have great AI technology. So it may be true like for the stage where I am, but as a company, I will not succeed if I don't have a strategy to really rectify and sanitize and make my AI better over time. And this is the way to create like a true business advantage over time. So as a seed investor, I think you need to look at two things. One is, can the startup get the initial data? You give them the funds, right? But will they be able to get the initial data that will help them start running and build their initial AI technology? And I can say that for us, the initial data was super meaningful, like from experience. But then that's only the first part. The second part will be, does the startup have a strategy that will enable them to get more and more data over time and create better AI over time? And this, like I think the joining of these two conditions, getting the initial data and having the strategy that will make the AI better over time, will actually give them the ability to create a real business advantage based on their work. So this is, I think, the key thing, and at least from our experience.
I think one of the challenges, and I've been doing software as a software developer back in the day, and in the last 10 years or so as an investor, is that sometimes the process is much less predictable, right? So it's very difficult to know exactly what the goal, what you're going to achieve in a year or in a quarter or whatever. So tell us a little bit about the challenges of managing an AI process or as opposed to a standard software development process as someone that manages the process and responsible for the deadlines and so forth.
Sure. So actually there are many challenges. So I think I'll select one which is interesting to talk about, and that's from algorithm to a product. So, okay, we got the data. Okay, like the data science cleans it, prepared it, tried stuff on it, and they have a great algorithm. Okay, so are we ready? Like, do we have a product that we can sell? So no, we're far from being ready, because the algorithm is great for the data we saw, but the product will actually look at multiple, data that we didn't see, and actually multiple types of data. So no matter how much data you have, there's always the stuff that you don't know. And in order to create a product, you need to work well with what you have, but also work well with what you don't have and conceive a generalized product. And this is a challenge that I don't think a single person should be responsible for that in the org. I think it takes teamwork of great data scientists, but also great product managers, great engineers, and great other players. And I think only this true teamwork can really enable productization of AI. So that's what I would say the main challenge. So,
cool.
So maybe I'll ask you, you see companies, like you have many companies in your portfolio, and I know that like many of them do have great AI. Do you see that as something that they gain advantage from in the market?
Yes, but again, I think this is one of the things that we need to look into very deeply as investors. And again, sometimes it's more complicated. It's try to figure out if in this specific use case, AI can really make a difference. Because honestly, in many cases, it doesn't. Or in many cases, just going the very simple route, creating something simple and straightforward, maybe will do the work without all the complexities and stuff related to doing, AR, IR, or to do more complicated stuff. So I think the challenge is really trying to figure out if there's a real business advantage. And also, and I think this is also important for, I don't know how many entrepreneurs there are in the crowd or CEOs of young companies, but I think to a large extent you need even to hide the complexity from the users or from the customers at the end of the day. So I'm personally not a big fan of complex systems that are discovered to the customers as complicated. Clients that needs to understand the models and to figure out what the model is doing and so forth. That's typically not a good sign. So I think, to me, great use cases are use cases that you can only do with AI, but at the end of the day, the method that they are being presented to the end users are super, super simple, right? So in a case, like your cases, if you can say, yeah, there was a hack to someone is trying to steal your car using whatever cyber attack, and the model, behind the hood could be very, very complex, but at the end of the day, the way that it's presented is super simple and very easy to understand. To me, that's a very good example of use of AI. Again, as opposed to situations where the UX itself is very complicated and the end user needs to understand, the models and so forth. That's typically not something very scalable. That's, to me, something that I'm trying to shy away from.
Okay.
Yeah, okay.
Good.
Good. Yeah, thanks. It's been interesting. If you have more questions, you can come to us afterwards. Thanks, Anya.
Thanks, Anya. Thanks, everyone.
I really hope this works.
You're actually leaving the stage, and another couple is coming up. So while Nir and Aaron are coming up, I'll introduce them. Our next company is Allegro Ai, and Nir is the CEO, and he will introduce himself. And Errol Applebaum is a partner at Misma Ventures, and he's the seed investor. And I personally am not familiar with Misma. How many of you know the fund? It's a new fund with Asian collection. So we want to know about the fund, not just the company, please. Thank you. Enjoy.
Excellent. Well, would just love to kick off with a giant thank you to Anya for inviting us and for helping to make this such an amazing event, and to her very talented son Uri, who's a dear friend of mine, and it's great to see him in from Berlin. So a moment about myself, about Misma, to set the stage a little, give some context, and then we'll jump into the actually exciting stuff, which is Nir and Allegro, and how we're really helping the AI revolution in some of the fundamentally missing tools. So Misma is a relatively new fund. We've been around now for 3 years. It's a concatenation of 2 Hebrew words, Mizrach Ma'arav, East and West. So named, we have a partner in Hong Kong, a woman who was formerly vice chairman of JP Morgan, running investment banking Asia. A partner in California, who's an entrepreneur, former general partner of Lightspeed Ventures. We have a partner in New York who ran IBM Israel and then fintech strategy for them globally. And the whole idea behind the fund is that we've got these consummate professionals with deep real-world experience coming together with a global network and an eye towards investing exclusively in early-stage deep tech companies in Israel. So the idea is to help these companies with really amazing technologies, with these breakthroughs, to bridge to some of the largest customers, licensors, buyers, acquirers of these technologies, of these companies, to add a lot of growth very, very quickly. Portfolio of 20 companies now, and one of which we are particularly excited and particularly proud is Allegro Ai. And with that, I'll pass off to Nir to explain a little bit about Allegro and what it does.
Sure. Thanks, Aaron. And again, thank you, Anya and team. So as I was listening before to Clemens and Chovav and Jonathan, I was thinking, what can I actually say that's new? Because in a way, as they say in Hebrew, הרימו להנחתה. They actually went through a lot of the problems that basically we're helping with. So Allegro Ai is a company that helps our customers with unstructured data, mostly around perception. So you can think of computer vision, but not just computer vision. It could be autonomous vehicles, medical, etc. But basically helping them realize a solution. And we do this by providing a platform that deals with a lot of the problems, and I can actually go through, I wrote some notes as we talked about before, as Clemens mentioned, data management, SKUs and management, which data do you want to deal with, where to find it, data privacy and IP. How do we help companies actually build things but not share data that's important to them or maybe to their customers? The combination that was just talked about with Jonathan on teamwork. How do you actually bring together data scientists and engineers to help? Because that's really where you need to get to a product. How do you work with some of the things that were mentioned here? Processes, right? The process of developing, QAing, continuous development, continuous integration, post-production of data models is different than the normal software. So basically that's what we help with. We provide infrastructure, a platform to address all those, I'd call it heavy lifting of things so that our customers can focus on the product. And we're a horizontal play. We're working with companies in automotive and medical and security and smart cities and what have you.
Excellent. So Clemens very elegantly made a comparison early on in his presentation between the World Wide Web and the value it's created and artificial intelligence and the ultimate value it can create once it takes off, once we get over some of these fundamental problems. So before we get into some of how Allegro unlocks these problems, I would love to hear from you, Nir, in some of the mirroring and some of the parallels that you're seeing in terms of the internet is not the product, it's the delivery mechanism. And without Google to index and allow query, it's useless. And without Wix to create easy-to-build user interfaces, it's less valuable. And we can't get the Amazons and the Netflixes and all the wonderful value. So I would love to hear from you for a second about where we are in the AI revolution in this life cycle. What's still missing? What are the gaps? And how are you seeing this problem set evolve?
Sure. So I think it's kind of interesting because in my career, I've been through a bunch of these adoption of new technologies, whether it's the internet, I was a long time ago in Bluetooth and other technologies, search. And it's interesting because there's always this adoption curve, and obviously there's a very big gap between the hype in the media and what's really going on in the field. With the internet, it was interesting because basically there was infrastructure that was created, and then applications came on top. To some extent in AI, we're actually seeing kind of the opposite. We're seeing companies going and trying to focus on the application, but the infrastructure is missing, right? This is from our very unique angle on, you need infrastructure to be able to actually build a real product. And maybe one way to think about this, there are a few companies who are very different. If you think of Google, Facebook, Microsoft, there's a bunch of these companies that to some extent have monopolized both the talent, but also really the understanding of what you need to do, what it takes. It's well known, so I spent a decade at Google before I joined or basically set up Allegro. And it's well known that over 90% of the resources at Google, and it's similar when I talk to colleagues in other, Microsoft, et cetera, areas, 90% of the resources go to build the infrastructure. I'm not even talking about the hardware. Everyone understands that they need GPUs, but the software infrastructure to be able to really take prototyping to a product. And most of the industry, 90 or something % of the industry doesn't understand that, and we've seen that time and time again. Whether it's startups or whether it's huge companies where they would put in data scientists and build an autonomous vehicle. We've talked to and we're working with tier ones and OEMs, and this is an example that comes up again and again. They'll just come up with a professor that they think is great in deep learning. Not necessarily the case, because the good ones are already at Google and Facebook. And then they bring in PhD students to do research science, and then a year later nothing comes out. Right? There isn't any infrastructure. There isn't any teamwork around product managers, engineers, etc. And it's kind of like people kind of like jump the gun and put the carriage in front of the horses in terms of let's build the applications before they set up the infrastructure. And this is changing, and obviously we'd like to think of ourselves as one of the companies that's pushing this change.
Excellent. And so a few times in the explanation, I think you're spot on in terms of cart before the horse. This is such a valuable tool, then let's go build these applications and let's go find cancer and let's go do all these wonderful things without taking a moment to realize sort of what the gaps. So if we dig down into that term infrastructure, right, there's a whole element of the tagging and the synthetic data creation and the indexing and the versioning and the storage and so maybe just break down for us what are the very specific gaps and how does Allegro tackle each one of those, because I'm sure both the entrepreneurs in the crowd who might be users or investors who are trying to build their understandings of what they should be looking for in companies. I think if we break down the product a little bit more deeply and tackle each problem, you'll in effect be addressing a lot of what Clemens was saying, a lot of what we heard from MDClone and others, and so.
That's correct. So, some of this is obviously most of you will know, but this all stems from the fact that obviously AI, and specifically we work on deep learning because that's where unstructured data comes into play, is a fundamentally different process, right, for doing software in general, right? It's a learning paradigm, and it requires data as what I'd like to say as raw material to drive the processes. By the way, not just development processes, but the QA, etc. That's really where things start from, right? And so what this means is a few things, right? One, data becomes a key aspect, not just as something that you get insights from or manipulate, but as something that you use as a raw material to build and drive the processes. The second thing is this is a learning paradigm, which means it's a scientific process, right? We're doing lots of experimentation, and this also happens in production rather than a linear software development process. So you need to manage a very different process. You're running lots of experiments at the same time. You want to compare them. You want to choose. You want to maybe go back because you've reached a dead end. So the other thing that you need to take care of is the process. In the data, again, Clemens brought this really nicely into play. The world of academia is very different than the real world. You've got data skews. Data is actually skewed by definition, and it doesn't matter any use case. So how do you actually find the valuable data? How do you deal with that? How do you create a search engine or actually, tag all the data and then be able to find what you need to and what's the more valuable data than the other? So again, you need a solution for that. You can't use normal or regular databases for that because it's a very different problem, especially if you're talking about unstructured data. Brought in synthetic data and privacy. So how do you actually, for example, as us, most companies don't necessarily have the skill set to build these solutions. So again, as a company that builds these solutions for other companies, how do we build something that respects the privacy of the data of their customers and the IP? MDClone mentioned synthetic data. We actually have a slightly different approach to that, specifically for unstructured data, to basically enable multiple organizations, think of multiple hospitals, share and we'll actually build models together without ever physically sharing the data. So the data stays behind the firewall completely safe, and they can actually leverage data from multiple hospitals or entities. So again, another solution to that. Synthetic data also, how do you actually create synthetic data on the fly, the right synthetic data? So all those things are, and then the last thing also, actually two things, is one, resource management. GPUs today, whether you buy them or you actually go on a cloud provider, are obviously extremely expensive as compared to normal compute power. How do you deal with efficiency? There are actually different efficiency problems and gaps in the pipelines when you do training. It's actually not the GPUs themselves, but actually the data bus. We've seen customers who've spent literally millions of dollars building their own data centers and then only to see 10, 20% efficiency on the use of the hardware, which is pretty common. So how do you deal with that? That's another issue that we help companies with. And the last one is really the point that Jonathan made on teamwork. Research scientists are absolutely fundamental to what we're doing here, obviously, but they're not enough. Ultimately, anything that you build is an exercise in engineering. And so you really need to build a team, but they're talking different languages, right? And so how do you bridge the science engineering? And some of the things that we do also in the platform is actually enable research scientists to go very deep in the technology, but then have those, what they create, be modularized solutions. Think of Lego blocks that the engineers can take and plug them into a real production product.
As a platform that isn't necessarily wed to one vertical, to one application, you've had the benefit of speaking to customers, potential customers in automotive and in retail and in media and in medical and in. So I would love if you could just break down for folks where you're seeing the best understanding, the most naivete, the most reticence to adopt some of this new technology, and the ability, either whether it's via capital or talent or some combination thereof, to adopt a solution like yours to really embrace this AI revolution. So I'd love if you could break down what verticals, what applications you're seeing, and then maybe also talk a little bit about the underlying asset that is the community. And I know that you've started to work a little bit, not just in this very sophisticated platform, but also within the community, within the open source community. So I would love to hear a little bit about the applications, the verticals, and then the underlying people who are contributing to this world.
Sure. So I think that first of all, obviously you need to have research scientists, and that's where, I mean, that's sort of like that's the beginning, right? And there we see, industries that are most further ahead. Medical is probably the furthest ahead, by the way. I think that they've been doing this for a while. To some extent, they haven't been calling it AI, actually. But we're seeing in the medical industry, really a lot of deep understanding of AI and deep learning. Automotive is also there. Obviously, they're huge because of autonomous vehicles. There are huge fundamental economic pressures on these companies, and so by design, they have to be there. So in terms of getting talent in the teams, that's happening there. Much less so in, obviously media or smart cities, and even in security. There are a bunch of, so one of our investors, Bosch, is certainly a very technical company, but most of that area is full of integrators and low tech, so they're less there. But then when you go and take the next step, which we talked about, do they understand moving from prototyping, moving from research to actual production, understanding there, the gap is across the space. I mean, we actually, I don't think that I can necessarily point to a certain industry that is more ahead than the other. It's really more specific companies that get understanding, and this is really where you find people in those companies that usually those would be the sort of like the VP R&D who come from an engineering background but have made the effort to understand this new technology and this new space, who really get that now they actually need to bridge the gap between the science and engineering to make it a real product. You talked about the community. So certainly we obviously we license an end-to-end enterprise platform, but we also have a solution called Trains, which is aimed at really the research scientists. It's an open source solution, and it's aimed at the community to help them get going, experimentation, prototyping, help them with DevOps, so they don't need to deal with DevOps. And again, another problem where companies are not set up in the right team. So that's there, and that community is we see obviously more professional data scientists and less so, again, because this is simply not a lot of them, and a lot of people are coming into this play because obviously salaries are high. But there's less understanding within the community because research scientists are not engineers. They don't want to write code necessarily. They don't know how to write code. Excuse me? we're finishing up. Yeah, so maybe one last question to Aaron? No?
It's all right. If folks are still curious about Allegro Misma, we'll make ourselves completely available after.
Allegro is one of the companies who is exhibiting in the startup pavilion upstairs, so you're welcome to go and talk to the guys there. Sorry, I'm the tough person. Everybody knows that. So what do you think of this format? Anybody who likes it, please raise your hand. Thank you. What about the rest of you? You were asleep. Shit. Anyway, so as I said, we have 13 companies exhibiting. 3 of them, additional ones, are going to do fast pitches, about 5-6 minutes each. We're going to call them one by one, and I'm going to take the time. That's my job today. And the first one is Ila Goldman Aslan, CEO and co-founder of Dia Medical from Beersheba. I'm going to stay here and watch the time.
Is it working? Now it's yeah? Okay, now it's working. Thank you, Anya. Right. Just stuck. So thank you for inviting me. My name is Ila. I'm the CEO and co-founder of Dia, and we are doing AI for ultrasound images. So I will start by telling you a little bit about the ultrasound market and the ultrasound area. So as you know, I don't know if you know, you can do evaluate almost any area in the body today with ultrasound. You can see the heart and the nerves and the bladder and the lungs and almost really everything. And I don't know if you know that, but there is an increasing use of ultrasound devices today due to several reasons. First of all, ultrasound is you do not have radiation like CT, and it's not expensive as MRI. And also, there are new users in the ultrasound market, what we call point-of-care users, that due to the fact that ultrasound machine becomes smaller and less expensive, there are new users in this market. And you can see ultrasound today on almost every area and every department today in the hospitals, and even family physicians are using ultrasound. And the market is huge. The market of ultrasound is $7 billion. And AI expects to reach almost 25% of this market. Why? Why we need AI for ultrasound? So the main reason is because most of the evaluation of ultrasound images today is being done visually by just looking at the picture, which is subjective, time-consuming, really depends on the user experience, and the variability is huge. And the need for AI to help them understand what they're looking at and also help them capture the image in the right way is substantial, and is all the time is increasing because of the new users and the new usage of ultrasound. So this is what we are doing. We are addressing the 2 main challenges in ultrasound: how to capture the image correctly, and through the streaming of the images, applying AI to find and help you take the image correctly. And once you got the image correctly, analyze it correctly, and help you make decisions based on objective information. So our vision is that wherever you will put the transducer, and it doesn't matter if it's a point-of-care physician at the emergency room or at the radiology unit, we will help you take the image and analyze it. Okay, so we have access to hundreds of thousands of images, and with that kind of an access, we apply AI solutions, both from deep learning, machine learning, and the traditional image processing techniques. And by that, we created a set of solutions that we already have a regulatory approval and already been sold in the market, with more than thousands of users that already bought some of our solutions. We are applying our solution. We're vendor neutral, cross-platform, on cloud, on the device themselves, on the healthcare IT system. Wherever there is a viewer for ultrasound, we are going to be there. So this is just to give you a sense. We are partner with GE. This is a handheld device, pressing one click, and within few seconds, getting results on the spot with the patient. Understanding here is a cardiac solution. What is the global function of the left ventricle? Capturing the image. Next year, we are going to release our solution for that. Real time, when put in the transducer, helping you with green and red indication where you are. Once you get to the right area, great. We will give you a green light, and you can go ahead. We're offering our solution through partnership that we have with channels, and this is how we get to the end user, which is the hospitals and clinics, and we already have 9 channel leaders and partners that we are working that offering our solution on their systems. And as I mentioned, more than 1,000 users that bought our solution, 20 countries, 9 leading partners, and counting. And our vision is to expand to various areas, to continue our sales and marketing activity with our existing FDA and CE-approved solution. And of course, we are doing it with a great team of engineers, business team players, and of course, physicians that are in our advisory board. And actually, when we're talking about physicians, I must say that those physicians that work with us do not see AI as a threatening. On the other way, they're seeing it as additional tools, additional instruments in their toolbox that helps them make better decisions. So if until now they had like blood tests, all kinds of devices, now they have also AI solutions that can help them make better decisions and based on very objective information. So thank you very much. It was wonderful being here. And thank you, Anna. And we're hiring, so whoever is looking for a job in product engineering, please approach us. We have a booth also outside. Thank you. Okay. Well, I don't think this works. You want to get mine?
Oad Sassoon, there is a delay, sort of. I'm not patient enough. Oad Sassoon, Business Development Manager, Razor Labs. You have 2 more before lunch, so be patient.
Hi, everybody. 1 second. Okay, perfect. So hello, everybody. I'm Oad Sassoon, and I'm from Razor Labs. Very happy to be here today. So Razor Labs, what we do. As our logo states, we empower organizations with artificial intelligence. We develop tailor-made solutions that utilize deep learning technologies to create hidden value and insight that can be translated to better KPIs to our customers. Some facts about the company. So we were founded in 2016. We are a bootstrap, never raised money. And we are already about 150 employees located here in Tel Aviv. We are already completed more than 55 projects. We are mainly active in Australia, where we have a local team and office there that we opened several months ago. And of course, we are very active in Israel with many types of industries and sectors such as manufacturing, retail, H&O, public sector. And in Australia, we are very active in the mining industry, which I'll elaborate about some of our solutions in a minute. Also, recently, Razor Labs has been selected to be NVIDIA partner in its most exclusive partnership program. This partnership includes only 24 partners worldwide, and Razor Labs is the only partner in the Middle East and Australia. Okay, our solution, tailor-made solution that we develop are focused on 2 main areas. The first area is the video analytics area, where we have developed a platform that we call Visual Mind. This platform utilizes deep learning technology to detect, classify, and analyze video stream and images and create real-time alerts, and I will show you some examples in 20 seconds, sorry. The second area that we build our knowledge and solutions is the area of data analytics. In this area, In this area, we have solutions for predictive maintenance and process optimization and machine throughput optimization. So, among some of our solutions that already deployed in a very large-scale mining company in Australia was a predictive maintenance solution that we also now developing a product for other industries. So this case study, our customer requested from us to develop a solution to predict manufacturing in a machine named car dumper. This machine obviously is a very valuable machine for him. So what we did that we received a 1-year-old data that was collected from thousands of sensors. We have been developed a deep learning algorithm and trained him. And after deployment, we were able to predict manufactions about 30 days ahead of time in 19% accuracy. Here you can see a snapshot from the dashboard that we developed to our customer. You will be able to see that our solution also indicates in which area of the machine a manufacturing will occur, as well to which sensor it relates. So it will also tell you, go and check the sensor in the engine area that related to the temperature, for example. Here is another solution that we developed to detect cars and classify between different kinds of vehicles. So, for example, you can see detection of cars, and in about 1 second you can see detection of bus in the yellow bounding box. Also, Razor Labs has an education department that we are very proud of that contribute back to the ecosystem. The most important course in our education department is our Future Learning Bootcamp, where we train about 8 students in a course that takes 2 months and make them to be our AI developers. So I see that I'm out of time. I will just say we exhibit upstairs. You are more than welcome to come and visit us and talk more about our solution. So thank you very much, Anna.
Takes time. Thank you so much. So our last speaker for this session, Amir Raskin, CEO and founder of Shudu. And I'm not going to come back and disturb you, so I hope you enjoyed the startup session and enjoy the exhibition. Oh, you have the thing.
פותחים לי את המדונה? פתחו לי. שלום לכולם. Hi everybody. First, thank you to IAA for giving us this opportunity, selecting us to be on stage. I should be finding the clicker, and here's the clicker. How many people here are using AutoML? None? No, you're too shy. Okay, so AutoML is considered to be like the next revolution in machine learning, because when you think about automatic, you say like everything is automatic, right? Not exactly, because if you think about it, you see that the change in 1934 from car with manual gear to an automatic gear shift didn't change anything. The driver stayed. What we do in Shudu is completely eliminate the need of a data scientist, and AutoML doesn't. AutoML, the next revolution, is in fact what we are going to change. We're talking about autonomous ML, which means that we speak directly to business. We provide machine learning, predictive analytics capabilities directly to businesses, and this is the true commoditization of machine learning. There are very few people who will agree that you still need a secretary, that you still need a driver, or that you still need an analyst or a data scientist at the customer side. Of course, if you are an R&D of Mobileye, you need data scientists. If you're at the center of Google, you need a data scientist. But if you are a retail company of a 1 billion, one of our customers, you do not need a data scientist, and you will not have a data scientist a few years from now, and this is what we do. We also change completely the understanding that a machine learning solution needs to be designed specifically for an industry, specifically for a question. This is the hot air that most of the data scientists pop into this domain So they can charge too much money for providing solution based on publicly available open source machine learning models if they are properly run in a platform like we do. So in fact, these data scientists are not going to be there out at the public. They are going to be behind the scenes in the R&D centers and not at the customer sites. So Shudu provides for business user autonomous solutions for predictive analytics in all kinds of business domains, and we predict sales, we predict calls to the call center, we predict credit faults, we predict technical failures of devices on an hourly basis directly from the log of a device, etc., etc. This is the alternative that most companies are facing if they would like to have the capability of predictive analytics. This is unbearable. This is something that most companies will not take. And as a result, machine learning, we can talk a lot about it here in this fancy auditorium, but it's not used. And we need to ask ourselves why. This is how design should do. I want to give you a very fresh, from a new customer, right from Wednesday, very fresh example of something that a few years ago would have cost $1 million. This is dynamic pricing solution. What you can see here, that these are, let's say, it's a simulated story, of course, tickets for a show. Let's say it's a kind of company who sells a lot of tickets to a lot of shows, and of course there is a limited number of places in the hall, and this is the orange line that you see there. And this is our prediction, well ahead of the event. At each price, the line here, is this the laser? This is the laser. The line here is the possible prices, is the dates, and these are the quantities that can be sold. Now, if you push forward, this is how they can maximize the revenue. In this case, in the simulated number, it's almost $70,000. This is what we predict. If they will play correctly day after day with the prices before the event, they will maximize the income, which is the important stuff. Not that all the seats will be filled, of course. And this is what they did. This is when we tested the data on what they did before, this is how they acted. And you can see immediately that they haven't been playing correctly, and as a result, they were hitting only half. Here it's written something like $30-something thousand. These are true numbers, not the numbers, but the proportions. So this is a clear example of using machine learning out there in business with a clear bottom line to the business. And we have more than 10 customers. We have started in an IAA incubator with POCs. Now we are publicly available, and we are pushing our service as subscription to companies mainly in Europe, UK, US, and in Israel, of course, and Far East. We already mentioned both in the recently published Deloitte retail landscape as predict with internal data category. We were mentioned a few times in the relevant Gartner hype cycle. We are very easy to use. Onboarding is less than a week instead of a few months of a project, and we cost something like thousands of dollars, a fraction of the alternative. Thank you. We have a booth. Come talk to us.
Thank you so much. Thank you so much. Number one, someone lost their car keys. So if you lost your car keys, just check it. Make sure you have them with you. If you lost them, just come to me and I'll give it to you. Pass the word around. If you meet your friends, ask them about their car keys. Number two, we have now the most exciting thing, lunch. And we're going to come back here exactly at 1:50. The next session will start exactly at 1:50. Enjoy lunch. Bon appetit.